Hello, you are welcome to our lecture on assembly drawings, and it's continuing from where we left off in sectioning. So in this lecture or discussion, we are going to be looking at what assembly drawings are. They will also take a look at some types of assembly drawings. Then we'll also discuss the steps that will be needed to make detailed assembly drawing. And in doing that, we'll solve a sample question that is on assembly drawing. So normally machines have several parts, okay, and of course an assembly drawing is an assembly of all these parts. So what exactly is an assembly drawing? An assembly drawing is one which represents various parts of a machine in their working positions. Okay. So what are some of the types of assembly drawings we have? First of all, we have design assembly drawings. And you normally have this particular type of assembly drawings at the design stage of any product. Let's say, for instance, you are designing a perfume box, which we did much earlier in the semester. Okay, so your initial sketches for that drawing will be your design assembly drawing. Okay. Then we also have what we call working assembly drawings. They are normally made for simple machines, and they comprise of a number of small parts. Okay, now these small parts are normally dimensioned to make it easy for fabrication. Okay. I would like to look at this as an example of a working assembly drawing. No. Okay, so this is an example of a working assembly drawing. This is actually a clamp, and it has all the various parts just in place for the assembled clamp to be able to work correctly. Okay, then we have sub-assembly drawings. It's actually another assembly which belongs to a bigger assembly, and you normally apply sub-assemblies in drawings which are much more complicated. Okay, so as we can see here, this part of the drawing with a magnifying glass around it is a smaller part of the bigger drawing. Okay, so what we have here in blue is actually a sub-assembly of the bigger part. We also have installation assembly drawings. So they reveal the relation between different units of a machine. Okay, they not only reveal, but they also give the exact location and the dimensions of a few very important parts of the whole assembly. Okay, then normally you see this when we buy new parts. Let's say you buy a new fan or a new furniture that you need to assemble. Okay, so this is an example of an assembly drawing. It has all the important parts, and it also gives the details of some of the details of those important parts. It also shows you how you do the connections to install this part. Okay, so first of all, when you want to work with an assembly drawing, what are some considerations you should make? Considerations, very important. You have to first understand the purpose or the principle of operation of of whatever you are dealing with, purpose, principle of operation, and the field of application. So what's the machine supposed to do? And then how does it work? And then where is it going to be used? Okay, right. So this will help you in understanding the individual parts and their location, and then functional requirements of the part. Okay. Then second consideration we should make is that we should check what parts of the different parts. Okay, like an assembly, of course, consists of several parts. Okay, so you pick every one of the parts of the assembly, you check where does it fit, which one goes into one, or which one surrounds the other, how is it connected to the other. Okay, so this consideration answers the question, what fits into what. Okay, the third consideration you should make is you should try to choose a proper scale that will help all your drawings to fit in the space that you have. Okay, and then lastly, you should estimate the overall dimensions of the views of the assembly drawing. I think we've been doing this for some time now, so we are quite experienced with it. Okay, so the number 3 and 4 is just part of the planning you are putting into the drawing you are going to produce. Okay, so that again you don't run into the problem of finishing your drawing and your some parts of your drawing are crossing your borderlines. Okay, so quickly let's look at the steps. Now we've looked at the considerations, what we should keep in mind as you're working with assembly drawings. Now, what are the particular steps you need to take as you work with any assembly drawing? You need to first of all locate the axis of symmetry for all the views of that assembly drawing. Okay, then normally you begin with a view in the front. Why? Because from all we've done in orthographic projections, you remember that the front view is the largest side and normally contains more details than all the other views. Okay, that's what you normally choose to be your front view. Okay, so you begin with your front view, then so your front view is the main part, and then you add all the other drawings in the sequence of the assembly. Okay, so you are done. You are not exactly done, but you started using your front view. Nextly, you want to project the other required views. Okay, so required, as in depending on what the question is asking you. All right, then you also mark the location and overall dimensions and the part numbers on the drawing. Okay, very important, you also need to prepare a part list. So if the assembly consists of various parts, those parts are made of different materials: steel, wood, fiberglass. All these are examples of materials that your assembly parts could be made of, and you need to indicate them in your final assembly. And do not forget to also include a title block. Okay, so the first example of an assembly we want to look at is something we call a universal joint. Okay, so just a brief description. It's a rigid coupling. It's a rigid coupling. So coupling is just another word for a joint, and it's used to connect two shafts whose axes intersect if extended. All right. So this is an example of a universal joint or universal coupling. I'll post the link to this video in my comments so that you can check it out yourself, so that you get an understanding for a universal joint yourself. All right, so back to the description. Then there are two forks. Okay, in the drawing I just showed you, they are colored gold. So two forks mounted at the end of two shafts, and then there is a central block. I think it's colored silver. Yes, silver. Silver with two ends. One pair of ends is green, the other pair of ends is red. Okay, so these are the forks, colored gold or bronze. I hope my color is right. Okay. So you have the central block, which I said is colored silver, having two arms at right angles to each other, placed between the forks, connected to both of them by using pins. Okay. So the pins are what we saw as red and green. Okay. Then of course there is a collar. Then a taper pin. It's not showing in that drawing. Okay. The taper pin is meant to keep the four pins in position. In other words, the taper pin is supposed to lock them up. Okay. All right. So once we have an understanding of a universal joint, which is basically a brief description I've given, let's move on to question 1 to solve for today. Okay. So the question is asking us to assemble the parts of a universal coupling as shown in the figure below and draw. So this is what is required of us. We are making a sectional view from the front and also a view from the left. So actually, forgive me, this should be a view from the right. We're actually making a view from the right. So forgive me. Okay, it's supposed to be from the right. Okay, so this is what you're giving in the question. This is what we are giving. And it's assumed that you already have an understanding of how the particular assembly you have been giving. You already have a good understanding. So that's the assumption. The questioning is going to be based on. Okay. So if you are seeing a question in your exam, or you are seeing a question which is something that is new, or which is something which you have not seen a description of, it will normally be an assembly of something that is common, like tissue dispenser or a doorknob or anything that's very common. Okay. All right. So these are the parts we have before us. Okay. As you can see, where I'm hovering my laser pointer over is a front view of one of the parts, and the same part, this is the top view. So top view, front view of part 2. Top view, section, front view of part 3. Then part 5, we are only having one part, it's not front and top. Then part 4, so we are having one part. Then part 1, we are having the front and then the left side view. And then for part 6, we are again having the front and the left side view. Luckily enough, we have the part list given us. So then it's easier to make your part list. Another very important thing you should take note of is that some of the named parts are 2 in number. So even though you are just seeing one part here, for example, part 1, you are seeing just one part, but in your assembly, we should be seeing two of parts 1. Okay, we should be seeing 2 part 1s. Okay, the same goes for part 2, which is the fork. Same goes for part 2, which is the fork. Once you are done solving our question, we should be having This is part 2. We should be having 2 of it. We should be having 2 of this in our final drawing. Okay, so we'll look at all that. Okay. Another very important thing we should take note of. So I'm sure you remember that aside the consideration, you remember the very important steps we need to take to work with assembly drawings. One of which was that, first of all, understand the purpose of the application of that particular machine. Then number 2, examine it thoroughly. So we are still at the examination stage. We've looked at all the parts and the quantities we have. Then you also choose a proper scale. We assume all that is done. You also estimate number 4, estimate the overall dimensions of the views. We assume that is done. Then you draw the axis of symmetry for all the views of the assembly drawing. Okay, we'll be getting to that in a bit. But before we leave this screen, one very important thing I want us to look at is that we have the section front view here, and this is the plan. Very important. Even though the section lines are not showing, you have to bear in mind that there is a section line. Okay, in this case, we have a section line running through. Okay, so there is a section. You can call it anything, section, whatever. Maybe this is XX. You can call it whatever. So this front view is actually a section XX. Okay, then same applies over this place. Oops, I have my section line wrong. Section line, correct my section line. Okay, so my section lining, big one, short, long, short, long, short, then a thick long one. Okay, with my arrow nicely. Okay, all right. Okay, so this is the kind of section that is giving us what you are seeing. Let's call this one Y. Okay, so this is actually section Y. So let's keep the sections in mind. Okay, the correct section lines. Just going to be like this. All right, so you can continue. All right, so this screen is all part of the understanding of in this case, the application of a universal coupling or universal joint. Okay, so you have 2 shafts. The coupling, there's one universal joint here, universal coupling here. There's another one here. Okay, so once you watch the video, you catch all of that. All right, so brings us back to our question. Now let's go to about step 5. So we finish with step 5, which is the axis of symmetry, especially of the axis of symmetry. Right. Next step 6. Okay. So now we are just adding. We have inspected the parts already. We have found out what part fits what part, or what is going into what. If you look at your parts correctly, because part 2 has a part that is 30. Okay, once with the understanding of the working principle of the universal joint, you know that this is the fork and the shaft will fit inside. Now, when you come down here and you look at this shaft, it has a diameter of 30, okay? And the opening in the fork, also has a diameter of 30, okay? So clearly, this shaft is going to fit into this shaft. Once you're sure of that, we are at the sketch stage of our drawing. Once we are sure of our sketch, then we can move to do our drawing on paper. Okay, so this is in the front view. This is I should say this is the largest part in the whole, in all the assembly parts. This is our largest part, and this is our parts. These are part 2. Okay, and okay, so these are part 2, and these are part 1. Okay, part 1 is the shaft. Part 2, fork. Okay, we discussed already. 1, because this dimension matches with this one, this is going to fit right. 1 is going to fit right into 2 from this end. Okay, I hope that is clear. And as you are doing the fixing, we should also be very careful that the axes align with each other. Very important. Axes will align with each other. Okay, so once you are done with that, you have your part 2, and you have your part 1. Remember, this initial stage of your assembly is only a sketch. It's only a sketch. So once you're done with your sketch and you have a hang of the whole assembly, you can proceed to do it using your CAD software or on your piece of paper. All right. So part 1, part 2. Okay. So we go again and look at the drawing. What parts face into what? In the front views of both parts 2 and 3, would see that these dimensions match. 56. This hole here, this recess here, has a height of 56, and this part 3 also has a height of 56. All right. Is there any other place? Is there any other part which has a similar dimension? The answer is no. So obviously, this part 3 will fit onto part 2. Okay, so once we are here, this part 3 is coming to fit here. Okay, so once you've done that, now we have 1, 2, and then the newcomer is part 3. Again, the axis of part 3, axis of part 3 Oops. This is part 3, and look at its axis. It's aligning nicely with the axis of the hole that is in the fork. Take very good notes of that. Right, so you are done with parts 1, 2, 3. Okay, next part is part 4. Okay, how do we know that part 4 is the next to join the assembly? Because part 4 has a diameter, okay, which matches with the diameter of another hole in assembly. All right, just take a look. part 4 has a diameter of 16, and then we're having the same diameter for the central block and the same diameter in the shaft. Okay, well, just look at it this way, that this pin, which is part 4, will fit into this hole in part 3. Okay, so if we do that, well, we now have 1, 2, this is 3. Okay, this is part 4. Okay, once it comes here, it's going to fit here. Again, its axis here, its axis running through the center is going to align with this axis. Okay, so once you do that, that's what you have. So part 4 arrives and it's fitting nicely in this hole. So from here, okay, here it comes, fitting nicely in its hole. Again, 1, 2, 3, and this is part 4. Okay. All right. Our part is building up. All right. Now you notice that in the part drawing, this shaft, which is part 1, was not sectioned. Okay, why? Because if you remember our discussion from part not sectioned, we'll know that anytime you cut through it, anytime you are doing sectioning and there is a shaft in assembly, you do not cut along you do not cut along the axis of the shaft. Okay, but if it's across the axis, as is being shown here, if it's across the axis, then you can show the hatch lines or you can cut. But if it's along the axis, we do not show hatch lines. Right? That's why there are no hatch lines shown here in part 1. Okay. But now we are going to have to add the next part. Now, if you look at the dimensions carefully, So we have assembly. Hold on, there's a part we left out. Sorry. So this is part 4. Again, on this part, on part 4, there is a dimension of 16. This rod has a diameter of 16. And when you look at part 5, which is the collar, there is a hole. The hole through the collar also has a dimension of 16. So this is part 5 is the only reasonable part that should fit onto part 2. Okay. So if you do that, you are going to have part 6. You are going to have part 5 here sitting on that. So you have 1. We have 2, 3, 4. Then this guy here, which is the collar, is part 5. All right. Then there's a newcomer coming. That newcomer is part 6. How do we know? Because, let me just go back to the diagram. Because part 6 has a dimension of 8 by 8. All right. Now, when you look at the keyway, it's giving the description for the keyway is 8 by 4. The keyway on the shaft. Take a look at the keyway on the part 1, which is the fork, it's also the same, 8 by 4. Okay, what it simply means is that half of the height of the key is going to be buried in the shaft, and the other half is going to hang in the fork. Okay, how would that look like? Okay, all right, so parts labeled nicely. Now, when you come here, part 6 has fitted into this place. All right, mind you, part 6 has a slope, but in the assembly, you can leave out this detail of the slope such that you can make this side of the key to be the same as this side. Okay, this is our sketch. That is why I have left it in there. Okay. All right. So you have our part 6 in there. But remember, when we looked at the parts list, looking at the part list, some parts had 2. Now they had just 1. Okay, so I'm calling the second inclusion of the fork. That's what I'm calling 2B. So the first one was just part 2. This other fork we are bringing in is same parts 2, but I'm calling it B. Okay, and remember, if you look at the working of the universal coupling very well, you see that the forks are where they are joined, they are rotated at an angle of 180. Okay, look, if you look at the fork well, you should see what I am saying. All right, so that's the fork. We can see the fork over here. All these areas, the fork. So this is the first fork, then this is the other one. Okay, you can see that this one, the nature of the fork, is rotated through an angle of 180 when you get here. Okay, so that is why the fork in this side of the drawing, fork is part 2. Okay, so this part 2 does not look exactly like this part 2 when you match them. Why? Because they are rotated. Okay, the nature of the working of the fork demands that the forks are rotated at 90 degrees before they join the central block, sorry. Okay, so you brought our part 2. Okay, now once you apply sectioning to your part 2, this is what you are going to have. Some of the parts. Remember, we said in section views, we are drawing a section front view. And remember, we said in section views, no hidden lines. No hidden line section views. So once you're making a section front view, we have to find a way of dealing with this hidden lines in the new part we have brought. Okay, now once you've dealt with that hidden line, this is what you have for the new part 2. So this is still part 2. This is the other part 2. The other part 2, again part 1. 3, 4. 1, 2, 3, 4. This is 5, and this is 6. Key. That's part 6. So this is the new part 2. All right. Then we are bringing another part 1. Okay. We already know why it is coming here. So that's a new part 1. Right. So there was a new part 2. There's a new part 1. We are bringing in. So as that part fits in, remember the keyway has also been rotated Okay, so let me just take the time to label this correctly again. This is part 2. This is part 1, the new one. 4, 2, 3, 1, 6. Then this is 5. All right. Okay, so if part 1, part 2, and take note, we've also included, there's a newcomer here. So we have this to be part 2, we have this to be part 1, and there's here's the newcomer, part 6, which is the other instance of the key. Okay, this is the first part 6. This is the new instance of part 6. All right. So again, we have not sectioned our shaft because we are cutting through our shaft along the axis of the shaft. Okay, so our shaft is not shown to have hash lines. All right, so there's one last part which we just added here. So help me count. This is 2, 1, and this part here, the key is part 6. Okay, and this is a newcomer, which is another instance of the pin. We are cutting across the pin, so it's needful that we hatch that section. What are we going to have? What part number is supposed to be here? Pin is part 4. Good. This is part 5. 1, 2, 3. See, this guy is 6. Are we okay with everything? Okay. So take note of the new positions, especially for all the new entries. Okay. And then this guy. All right. You notice that all of them have been rotated through 90 degrees, sorry, 180 degrees along this axis or above this axis. All right. So in this part of the drawing, we finish our sketch, okay, which I said is very important before we can move to making the real drawing. We've done it with our sketch. Then, okay, so if you are drawn with the instruments or had used a CAD software, this is what you will be getting for your. This is what you should be getting for your front view. Oops. You're getting this for your front view. Okay, that's where I'm hovering my mouse. Where I'm hovering my mouse. This is what you should be getting for your front view. Okay, if you have used the instruments. Okay. But then the question goes on to ask us for the right side view. Okay, so once you're done with the right side view 2, this is what you'll be having. Okay, because in the right side view, this is our right. So we are viewing from this direction, and viewing from this direction and projected onto the left. Okay, so this is actually our right side view. This is our sectioned front view, and this is our plan. The question did not ask for the plan, okay, but I'm just including it for the purpose of explanation. All right. Okay, so we are done solving our questions because we have this and we have this. Okay, then lastly, again, for the purpose of explanation, if we put our section lines through this, okay, so this is I'm calling this section A. Okay, so AA is what is giving us this view, all right? And then I need to put the section line over here too, okay? In the top view, the section line is going right through the middle, okay? Over here to our section line, okay? So this is what we should have. And this, okay? It is still section A. Okay, remember when we're discussing sections. So you, the observer, you are here, you are at this side, observer at this side, and once you view everything here is going to be thrown away. Everything here in this, everything here, which is to the left of the section line, is going to be thrown away. And this is the projection. This is the front projection of what is left. Okay, this is what we have left. This side here is what we have left. So it is in the side view. Everything here is in the side view. Everything here is in the side view. So once you make a projection of the half that is left, this is what you get. Okay. Now it is also important to take note of the fact that on the initial slide, we used a full sectioning. We use a full sectioning, but we notice that there's some symmetry here, symmetry along this line. Okay, that's a line of symmetry. Okay, so that line of symmetry is offering us the advantage to exclude one of the sections, either above the symmetry line or below the symmetry line. Okay, so from here, where we can clearly see a symmetry line, this is what we are getting now. Okay, so the section, the hatched lines in the lower part of the section front view has been excluded. We've taken that out, and we are leaving only the ones at the top. Okay, so remember, we can do that because we have a line of symmetry and we can afford to leave out one of them. Also, take very important note that around the key, see what we have done. We have created a broken out section just around the key. Take note, a broken out section. All right. So I think we have achieved the objective of this particular discussion. We have looked at what assembly drawings are. We have also seen the types of assembly drawings, and then also considerations and steps used to make assembly drawings. Okay, then we've also gone through the sample assembly drawing question. Okay, now it's up to you. This is an exercise, but you are going to take it as an assignment because this didn't happen in the tutorial class. Okay, so you are going to have this as an assignment, and I'm expecting this drawing on this slide from you, excluding the top view. Okay, so oops. This is what's expected of you. This, of course, the section line should be shown, and then this is not part. top view. It's not flat. Okay. So encourage me to make more videos, like my channel, post your whatever questions you have as in the comments section. I'll see you again. All the best. Bye.